Welcome to the Chemistry Live channel. Today we are discussing how to draw a structure using software in chemistry module 4, retrosynthesis and synthesis of aspirin. So how did you define the retrosynthesis and synthesis of aspirin, because it's a well-known drug? So as usual, pick the benzene because it is a benzene containing drug. So you have to know the structure of the first of all the structure of that stuff. Then place again CH3 here on the top and try to replace with COCH3 here directly. It is better option. Okay, and then place O here, better option. So that is the main group, and this is the, for our conveniency we have to put like that. If you face something difficulty like that, then did a one stuff. That's why I just wrote like that to let you know how difficulty you are facing if you do it like that. Then okay, so again use that CH3, Suppose when you are facing such kind of difficulties, when you start trying to draw something, then you are going to take care of that stuff. Okay, so basically what you do first, place the both sides CH3. Okay, don't go that side because then this OH group make a hindrance for you guys. See, that OH group make a hindrance for you. So it is better option to just make a far away from that one. So put it here, one CH3, and double bond O is here. So you have to use like that. That is quite easy. And put it O as well as here. And then you can delete this CH3 because then we don't need the CH3. We cannot mash up with this one. So that's why we are using this kind of approach. Okay. Or also you can use this side, doesn't matter for me. If you can use this side, both are perfectly fine. Okay, this is the structure of aspirin. And first retro, what we did in first retro, basically when you are in hurry, you can just make a mistake and draw a structure in a good manner. So be careful and draw structure linear. No? Okay, so then first we are discussing the CO. CO means from where? This is from CO disconnection. So write down here that it is the CO disconnection. C dash O disconnection. Okay, and try, if you don't want, try to small it this arrow because it's too big and it is unnecessary to use the big arrow. Copy that whole stuff and try to make as nearer to this one as we can. Okay, this is aspirin, and now this is the CN disconnection. And then try to copy here in that manner. So we don't need to write anything, just copy till here to here. Copy and paste option, just you can put it here. It's directly converted to OH. This is our product actually. Basically this is our product. Then again you make a disconnection of the CC bond here from here, and then CC bond disconnection we get a phenol. That is quite interesting. So we get a phenol from the CC bond disconnection. So again take a disconnection arrow, write down CC bond disconnection. So then you have to select only that portion, just remove this. If you don't want, then just remove. To copy that stuff, just copy and paste it here. This is phenol, our starting material. So now from phenol we can start the compound, but before that we have adjust this little bit upright position, so it is better to look. This is CO disconnection, this is CC disconnection. It is also very easy to draw it here. So to save a time, I will just again draw this phenol to start that compound from here. Okay, basically from phenol you get a salicylic acid. That is 3-step. It is a 3-step reaction. It's Kolbe reaction. If you are heard them Kolbe, then this is the Kolbe. But what is the Kolbe? And it is important to get an idea about the Kolbe synthesis. So first you have to do something like that, O and sodium. If you are ONA, and then you have to switch from ONA to here. It means something like here, there, and the final step is our product, our aspirin. It is here somewhere like that. Okay, so now start the complete positioning of all stuff and complete the write down the arrows. This is the using the NaOH. So I would like to use this. First I want to make this whole arrow to avoid such a problem. Okay, so then put the information here. I would like to put NaOH here, because then it's make a sodium phenoxide ion. Then sodium phenoxide react with CO2 and H plus. So what is the next? Next I would like to pass the CO2 stream or CO2 gas, and then second acid attack. Then I will get something like that, benzoic acid here at the ortho position, and H plus to remove this ONA to OH. It's quite simple. And then the last step is to react with acetic anhydride, because now we are creating CO bond. So CO bond formation is to use acetic anhydride. So the last step we are using acetic anhydride. Okay, and that is our compound paracetamol. Sorry, aspirin, not paracetamol. Sorry, this aspirin. So the aspirin is like that here, and we are just taking more the parameters like generate the name, okay, to acetyloxybenzoic acid, then calculate the formula weight, copy the clipboard, it is somewhere here, so we can put it down, the formula weight, and then again use the tool, calculate the molecular formula. This is a molecular formula. Then again click a tool and calculate M plus. This is M plus ion peak if we are taking a look for mass. Okay, so that is the IUPAC name basically, and phenol is also the phenol. If we take a look of the IUPAC name of phenol, so last we will see that is only phenol. So this is the phenol. Thank you for watching. Please subscribe the channel and press the bell icon for more notification.